Hello, everyone. Welcome to this week's Rochester Xamarin user group. It is April 8th, 2020. And as always, I can never figure out how to work PowerPoint with the GoToMeeting. But I'd like to thank our sponsors. .NET Foundation provides us the meetup.com account. And so you guys can all know how to get here and we can have it on your calendars. And File on Queue is my employer, and they provide us the GoToMeeting so we can provide the user group virtually for anyone in the world to attend. This week, we have Rodney Littles here to talk to us about ReactiveUI and Taming Mutable State. He's been a developer for over 15 years, works with on ReactiveUI, and is Microsoft MVP, and has a very long list here of credentials, which I'll let him reintroduce himself, but we're happy to have him here and looking forward to this presentation. And if anyone's got questions along the way, feel free to drop them in the chat. Rodney asked me at the beginning that we have an interactive session here, so please feel free to ask a question. If you're embarrassed to ask it, you can privately message it to me, and I'll be sure to ask it. Let's have a lot of good questions for him. And I will make you presenter.
Oh no, which means you can see my screen, yes? Let's do screen 2, yep. And let's hit the play button there. All right.
Your screen.
Great. All right, so first off, welcome. I definitely want to thank Andrew for asking me to come and do this. I really do appreciate any opportunity I get to talk about this topic. I found ReactiveUI probably about a year into my Xamarin career. Michael Stonis was on stage at the last Xamarin Evolve to ever happen and was talking about building better mobile apps with reactive extensions. And of course, I wanted to build better mobile apps, so I was like, hey, let me figure this out. That's 4 years later, here we are. So we'll just go ahead and jump right into it. So yeah, I'm Rodney. I'm one of the maintainers of ReactiveUI. I am a .NET Foundation member and I'm a Microsoft MVP. You can find me on the internet at any one of those places. Twitter is a great place to find me. GitHub, I do a lot of code. Starting to do a little more live streaming specifically on reactive concepts and how to use them in Xamarin applications because I am a Xamarin developer. I've been a Xamarin developer since 2015. Before that, I was doing large-scale enterprise stuff, and I found Xamarin, and it was the first time that I found like a platform that did UI that I actually enjoyed. I was able to build mobile applications. Before that, I tried like Ionic and Cordova and a couple other little things that were out there, other cross-platform technologies that were out there, and none of them really felt good. And Xamarin did because I'm a C# developer. I have been for 15 years. I love C#. C# is an ever-growing, ever-evolving language, which is part of the reason why I think I love it. So I'll talk about kind of the ReactiveUI team real quick so we can get some of the formalities out of the way. So this is the maintainers past and present. We are part of the .NET Foundation, so we were actually one of the first, we were an early adopter of the .NET Foundation. System.reactive is a library, the reactive extension library that powers ReactiveUI, is a Microsoft pet project. It was founded in Microsoft around 2009 by Eric Mayer and Wes Dyer. So Microsoft actually led the charge in the reactive space, but it seems that Microsoft developers are the least populated user group of the reactive extensions. So just kind of what you see and what you get. Today we're going to talk about kind of what is mutable state. We're going to define it. We're going to talk about what is an observable. How do you use observables to tame this mutable state concept, and using link to events to query event notifications. It's kind of like a boilerplate nicety. And if I have additional time, like if I run short because I talk fast, I apologize. If I run short, I've got like plenty of code samples to go through so that I can bore you to death all day. And the slides are out of order, but yeah, so if you want to know more about us afterwards, you want to talk about Reactive UI, you want to get more information on reactive extensions, you just want to drop in the channel and say, Reactive UI sucks, come on in and we'll be glad to engage you. The actual creator of Reactive UI and Reactive Coca, believe it or not, is still in the Slack channel answering questions. As a matter of fact, she answered my first question my first day. And I'll also get this other little piece of formality out the way, like I use Fire code. So people always ask me when I present, what is that funky stuff that happens in your code? It's just Fire code, it's ligatures. You can go find it on the interwebs, and there's actually a couple more ligatures that are coming out of the work nowadays. And the last piece of the formality is just defining some terms, reactive terms. So there's this concept of declarative, which you'll hear me talk about, and it just expresses the logic of computation without describing the flow of that logic. Observable is basically just a push-based collection of values over time. It's actually the dual of IEnumerable. So if you've been following any of the new stuff that comes out, some of this IEnumerable async stuff is actually kind of a play on trying not to use observables. I kind of call it like observable lights at this point, but it allows a collection of values over time. Operators, they're basically just link functions, but you'll hear me talk about observable operators. Subscriptions are how we invoke a function at the end of an observable pipeline. So it's kind of how you actually do some work. And then composable. Composable things are stateless, self-contained ways to arrange objects. So now that that fun stuff is out of the way, out of the tar pit. Some years back, I think it was like around the early mid-2000s, Moseley and Marks realized that the majority of the complexity in applications, modern applications that we build, come from application state. When things in our applications happen, we have to change values based on those changes, update other things based on those changes, and the entire system starts to react to the button click or the user typing into the text box or whatever the case may be. So this is what they realized, through conversation, and they wrote a whole white paper, which I believe that's the link that you can get the white paper. I found it in a couple other places, but it's not a good read, I'll tell you that much. But it is good information, because the gist of it is what they came out with is, based on the understanding that state mutation is the biggest complexity in our applications, they decided that they needed to find a way to mitigate and manage that state complexity. So mutable state. First off, kind of what is state? State is really just a value at a given point in an application lifecycle. Point in time, I don't like to use time because time is actually relative to the application, but it's just values at a given point. So the state of your application changes the second the user clicks in, and then when they type something else in the text box, the state changes. And every single time that a user interacts with your application, state changes. And we realize that as Xamarin developers quite a lot, because we deal with all sorts of state changes. The battery has a state change event. The connectivity has a state change event. The display orientation has a state change event. Like, all of these things are things that happen that are outside of the control of the programmer, but the programmer has to be able to respond to them efficiently. And as a mobile developer, I think that this is very pointed, because I've written plenty of applications, web applications, and MVVM. As a matter of fact, let me stop here. Everybody, I'm sure, is probably familiar with MVVM, which is just model view, view model. A lot of the web concepts really don't relate to MVVM that well. They're really kind of more like that model view controller concept, but MVVM is a very big part of the .NET space. And we're trying to figure out how to update our application based upon state changes that the user gives us, that our environment gives us, because we're working with a device that has limited resources. So even the iOS memory, I want to say is an event that you can get to at some level. Or I think it just exposes a delegate, but I'd have to go back and look. So when we talk about state, we're really in that's really what we're talking about. Is like what is the current this current moment, this current nanosecond, what is the state of my application? And mutability is really just, the changeability. Mutable just says that I can change this thing. So really what we're talking about is changes in our application over a given span of time. So things that we try and figure out is like when the state mutates, how do we make sure that we respond efficiently? When state mutation, is the mutation actually encapsulated? So meaning, does the outward caller of the state change have access to modify the state directly, or did we encapsulate the ability to change that state in some service or some class that's abstracted away? Those are things that actually matter that I never paid attention to before I started writing Xamarin apps, but when I did and I started using MVVM, like these things actually mattered. And again, when state mutates, like does it spiderweb? So when I change this property, how many other properties have to change or respond or be notified or do something as a result of that mutation? So when the user puts a value in the text box, what has to happen? Like, what are the things that are affected by that change? Any questions, any cares, comments, concerns? Okay. I'm going to keep asking just because feedback is always good. So this should look familiar to anyone that's written an MVVM application. This is just a command. This command is, probably put into the Xamarin Forms binding engine using the binding, command context and passing some command that exists in some view model, and basic MVVM, right? Just the commanding pattern with MVVM. So the first thing we'll notice here is on line 53, we're checking to see if the view model is busy, right? We're checking the state of the view model to determine whether or not we can even execute this. This right here is probably the biggest thing that I appreciate when I deal with reactive extensions, ReactiveUI in MVVM these days, is I don't ever have to worry about these things because of the platform niceties that ReactiveUI provides and the ability to compose declarative pipelines. But the first thing we're doing here is checking to see if it's busy and if the state of the object allows us to go do work. The next thing we're going to do on line 63 is actually explicitly set the state to is busy true, which will probably notify anybody else or any other command that may be happening in that view model that, hey, if you're checking to see if is busy is true, you can't do any work now either. And then down in the finally block, we're explicitly freeing up that is busy. So I actually had somebody ask me recently, what does a using statement really look like? And really what it is, and what we boiled it down to, is it's a try finally. You can kind of just skip the catch, but the using statement basically is just like, do this thing, and then at the end of it, clean everything up, right? Clean up and dispose of all of your stuff. So here in this one chunk of code, this one command that we have in our view model, we've explicitly checked the state to determine whether or not we can do work, and we've set the state to tell other people that they can't do work, and then we've then freed the state up again. So this is all mutating state, right? This is me, the developer, mutating the state explicitly, and I am imperatively telling the view model, hey, you can't do work anymore because you're busy. And then I'm at the end saying, okay, you're no longer busy. Well, what happens if that asynchronous call takes 30 seconds where normally it only takes like 30 milliseconds? What happens in that space? Well, what you're going to have is you're going to have a view model that's just busy, and it's just busy for no reason. And then I don't know how many people have used poly, but to do any type of like retries and backoffs. But then it also becomes even more complex when you're trying to do stuff with poly, because now whether or not the state is in the correct place, you now have to worry about whether or not the state is correct when you go to do the retry. Like, all of these things start to matter, and it becomes very, very cumbersome, and you're really just mucking up your own code. So a contrast to that is an observable pipeline. And I point this code out, and I'll state that, and Andrew and I were talking about this before we started, that this is a very opinionated approach, right? But at the same time, it's really not. It's actually very akin to things you already know. I recently did a talk talking about how observables are really just link over events, like you have link over SQL or link over objects, because you can use SQL style functional operators over a stream of data that is happening over a period of time. So a task will fire off and it waits for one value and then it's done, right? Well, an observable will fire off and wait for a completion notification or an error exception that tells you that there are no more values coming, or this pipeline is no longer going to function correctly because it errored. So this is a very big contrast, because it takes a very keen amount of breaking your brain to start to model your thought process in this manner. But the main things that I want to talk about, and I think I actually have a live, actually no, I do. I have this code live, so I can actually show you what this does later. But this is basically just system.reactive. Line 132 is ReactiveUI, but this is just link over events, right? So search text is a property on the ViewModel. That property on that ViewModel emits an iNotify property changed event, and all that when any value does is say, when a value changes, when an iNotify property change event happens, give me the value, give me the new value. So that's all that operator is really doing, is basically just conforming to the iNotify property change event and giving you a value when that event happens. So what we're doing is, in this statement, is we're basically delaying the processing of the statement. You know, we're saying don't give me any values until the last notify property change happened 0.25 milliseconds ago, which is actually really short, but such is life. And then we're going to explicitly tell it to do this processing on the task pool. So now we're getting into threading, right? So we've all written Xamarin applications. We know that main thread lock on iOS is a pain, right? Main thread on iOS locks, application crashes, you get your SIGBART, and you go to try and figure out where did you mishandle some configure await false or some configure await true. In reactive extensions, we can explicitly tell certain operators and the pipeline itself where to process and when to process. So we're explicitly telling that throttle to happen on the background thread, so we're not gumming up the UI thread. So then from there, we're going to check to see the state of the event change and make sure that it actually gives us a value. We're selecting out the value. We're explicitly telling the code that we only want to process new state. So if you're typing in and you type in comma, right, the actual word comma, and then you back it out and you type it in again all during that throttle, you won't get a new event notification, which is a very different concept from what most people are used to, because when you subscribe to an event handler right now, like you do like the text change event handler on a Xamarin Forms text box, or it's not text box, but on the text box, you have to process every single event. Here, I'm only processing events when and where it makes sense based upon my business logic. I'm explicitly telling it to then go back to the main thread when it's done doing its work. And then I'm invoking a command I'm invoking a command over whatever value I get. And then that dispose with basically just says, hey, when this disposable, and I'll show you that in a little more detail later, when this disposable is cleaned up, go ahead and clean me up too. So it allows us to batch disposal of those iDisposables. So observables are tools to combat mutable state. And I talk about combating mutable state because I'd like to think of myself as a developer in the trenches fighting with this application and trying to make it work. Because, you know, I'm not the smartest developer in the world, you know, spoiler. And there are times where I will look at code and it just won't make any sense. And I feel like I'm fighting with the code to make it work. So when I talk about combating mutable state, I'm really talking about defining that state using a declarative approach. So again, declaring what should happen as a result of a state change, as opposed to explicitly saying, hey, change this state and then go do some work as a result of it. I'm centralizing the management of that state. So all of that code that does that work is going to be in one function. Generally in reactive programming, we put it in the constructor. So in your constructor, you'll have all of these pipelines that define how the application should respond to state changes. And then you can just use the Xamarin Forms binding engine to emit those changes to the view in certain places. Observables themselves do not actually play nice with binding engines, so we've got some helper methods in the framework that allow to make that easier and to actually propagate properties anytime an observable ticks. So I know I kind of did that out of order, but I did it out of order on purpose because, you know, now what is an observable? An observable is really just the gang of four observer pattern, right? You've got some observer and some which subscribes to an observable, and when the observable ticks, the subscriber gets notified of the thing, and if it can process on it, it'll process on it. Reactive extensions are a cross-platform, I won't call it a spec because it's not really a spec, but it's kind of a spec. But reactive extensions is a cross-platform spec that tells us how these different operators should act across platforms. System.reactive or .NET Reactive is the .NET Reactive Extensions library. And this has become the standard approach for a lot of languages. JavaScript, Kotlin, Swift UI is using it now. PHP has observables, and it seems like everybody outside of the .NET space is kind of moving to this standard approach, because the task parallel library, while good, and while it solved a lot of concerns in the early days of asynchronous programming, has its limitations. Again, I told you it's one value. So I call out, I get back one value, and then I have to make another call, and then I have to make another call. Whereas observables just sit there and kind of wait for data to come to them. And when data comes to them, they just got to do what they're supposed to do, or they do what you told them to do. So in that vein, observables are asynchronous. They're awaitable. You can actually use the async and await syntax with observables, although I don't very often. On occasion, I will. And they're disposable by default. So they actually return the subscription of a disposable or of an observable returns an iDisposable. Yeah, okay. So observables are also very much like events, right? They just are notifications. So something happened, something happened, something happened, something is happening, something happened. That's basically all an observable is just an open pipe where you can push data in. Where an IEnumerable is going to be, hey, go get me this chunk of data, go get me this finite set of data. IObservable says, hey, give me values on this stream until I'm done with you, or you're done with me, or you error. It's reactionary. So when the event happens, there's some code somewhere else that's supposed to do some work, right? It's not like a procedural or hierarchical program where you have to write every single line in sequence. It's very much decentralized, which gets us to the next point. It's happening all over the code, right? In event fires and wherever somebody is subscribed, they can, or listening, they can get a value, and it's asynchronous, right? Because of the nature of events, right? You don't actually sit and wait for the event to process. You just fire off the event. So the thing that's firing the event isn't actually waiting for you to process the event. All it's doing is firing off events, and anybody that's listening can do something with it or not based upon how it's programmed. But observables are actually like really better than events. So again, they return an iDisposable. I've created memory leaks out the wazoo when I was a fresh Xamarin developer, because I didn't understand that when you created a delegate, you had to cache the delegate. So the first time I spun up Xamarin Profiler and profiled my app, I saw all these memory leaks, and I was like, oh my God, what do I do? And all I had to do was go back and implement iDisposable, but observables give you that power by default. you can time shift the responses. So again, I can buffer, I can throttle, I can tell you only give me events every 3 seconds or every 100 events. I can defer the execution. So I can literally say, hey, don't process this right now, process this later, or process this on another thread. I can wrap events in observables. So observables and events are interchangeable in my world where observables are. I can use event handlers or I can use observables, and I can model event handlers as observable pipelines. And again, you can use link operators over those events. The last part about observables, they can be scheduled. The TPL has this concept of schedulers, which is like configure await false, which basically says, hey, return on any context. You don't have to return on the context that you came on. The way I usually explain that is when I'm sitting at the bus stop, when I get on the bus to go to work, I don't have to wait on that exact same bus to come back to pick me up. I can pick up any, number 4 bus to get back home. I don't have to wait on the exact, 2319 serial bus to come back and get me. I can come back on any bus. So that's kind of really what configure await does. So it's kind of like schedulers, but in the observable world, I can actually schedule work to happen on different threads, the background thread, the immediate thread, the UI thread, and I can tell the code to do its thing wherever I want it to. And again, you can time shift execution, which is really one of the biggest things that I love about observables. So at this point, Rodney's done enough just rambling, and usually at this point, people are like, just show me some code or get off the stage. So I'm going to jump into some code. And yeah, here we go. So this is, of course, not where we want to start. So we talk about mutable state and state mutations, and I'll go ahead and tell you, pay no attention to the man behind the curtain, because this is ReactiveUI's specific way of doing bindings. This actually does not use the Xamarin Forms binding engine, so there's a lot of reflective magic that goes on in here, and a lot of people ask me, are there performance concerns? I've not found any, and the reason why I use this is, again, because of this dispose with. It allowed me to clean up all of the bindings at one time, as opposed to having to do some additional stuff. Like all I have to do to dispose of this is do view bindings not dispose, and every last one of these will get disposed.
Rodney, could you make the font a little bit bigger?
Yes, I can. I can make that as big as the IDE will allow. Tell me when to stop.
That's good.
Problem is I'm going to have to go page by page, so forgive me. When we get to the next page, I'm going to do it again. So I'm doing this in the on-appearing. Normally, I would do this this work in the constructor, but for the purposes of this, I actually did it in the on-appearing to point out some things with Xamarin and the fact that the on-appearing is still broken in Xamarin iOS since like 2016, and they haven't fixed it. And I yell at the Xamarin team probably every chance I get to fix it, and they don't. Anyway, so this is just me setting up bindings, right? I'm just setting up, the email address, the text entry, and all of these things. And again, this is MVVM, so I've got some ViewModel binding context set behind the screen. I'll go ahead and increase the font again. There we go. Is that better? Is that good?
Looks good to me.
So here, I'm sorry?
Looks good to me.
Good deal. So actually shrink that down so I can look at a little more code. There we go. So one of the things about it is, so like I'm sure everyone here that's written a Xamarin application has used an MVVM framework, whether they rolled it themselves or whether or not they use it. In Houston, Prism is the popular framework of choice. And I tell people ReactiveUI is an opinionated concept because it's a functional programming approach, but it's not opinionated in the fact that it's a full feature framework. It is a full feature framework, meaning it checks a lot of the boxes that you want from an MVVM framework, but it's not opinionated in the sense that I can actually use Prism and ReactiveUI side by side. I can use MVVM Cross and ReactiveUI side by side. I can use Fresh MVVM and ReactiveUI side by side. So you can kind of pay to play and get what you want and use observables where they make sense. And and only use them where they make sense, because it's a very daunting thing when you first starting. There's a learning curve. I'll admit it's a very steep learning curve. It took me about 3 to 4 months before I felt comfortable writing this code. I would come home every single night and my wife would look at me like I was crazy. I would be sitting there watching videos of smart people tell me things that didn't make any sense to me whatsoever. And eventually one day, like the light bulb clicked and everything made sense. But this is just a view model that you would see. You know, I am injecting, you know, using solid principles. So I'm injecting an eye authenticator and an eye connectivity, which makes my view model immediately testable, and makes all of my reactive code testable, just using, you know, straight up XUnit and, you know, some XUnit magic right on top of the view models, and I'm good to go. I can actually test that the state changes. Again, we're talking about mutable state. I can test that when these things happen, that the state change, the property is loading. So I don't use as busy, I use as loading the majority of the time when I'm doing loading data, and then like busy for something else. But this is loading gets a value, and I can bind that out, as you saw, to the view engine, and I'm binding that out right here. I'm basically just saying, hey, when this activity, when it's loading, run this activity, make it visible, and enable it, right? So there's no real magic there. There's no real special stuff. It's all just kind of straightforward. But the magic comes in where I'm doing, you'll see like this when any observable. So I'll kind of talk about this for a second. ReactiveUI started as a set of extension methods over observables, and those extension methods kind of became the core of the framework. And it's really just extension methods that you probably would have written on your own after using observables over a set of time. The creator was actually working at GitHub when she created this, and the GitHub desktop app was written completely with observables. So it used observables to model events and asynchronous programming. So from what I'm told, and I don't know, what I'm told is that there was not one task await anywhere in that code, which is candidly way far beyond what I'm willing to do. But I know that a lot of asynchronous programming is done task-based with the TPL. So, you know, observable, the system.reactive gives you the ability to wrap asynchronous tasks and provides an observable back. So again, it plays nice in the sandbox with kind of everyone. It's a way to model asynchronous programming, and it's a way to model events. Pardon me. So here I'm basically just saying whenever this command, right, whenever this command is firing, I'm going to change, whenever it's executing, I'm going to change the is loading. And I'm going to change the is loading based on whatever the value is. So when it's executing, it'll be true, and when it's not, and when it stops executing, it'll be false. The interesting part about this, and what I try and tell people, because a lot of people say, "Oh, Rodney, that's, you know, that's boilerplate. That's easy. I can write that." And I absolutely hate contrived examples. I can't stand them. But when I'm talking about this, I have to use contrived examples, because otherwise it immediately goes over a couple of people's heads, and I see people in the back of the room, you know, start to do other things because they're just tuning out. But what this when any observable will allow me to do is, like, let's say I have another command that I want to use, right? So in our earlier example, that is busy, we were setting it in every single function. So that state was mutating everywhere. So instead of that state mutating everywhere, I can basically say, hey, when that cancel command is firing, right, is executing. Can I do that? Oh, here we go. Live coding is such a real thing. So now what I'm saying is I'm combining these two observables, right? So now it's not that I have to go into each function and set my is busy to true, set a finally, and do all that jazz. Right here in my constructor, the only thing I have to do is add more processing to this when any observable, and it will add those values, and when those values happen, it will emit. So now here it's actually going to have to do like a selector. So I'll do like C1, comma C2, so that I can then get that out, because that'll give me, does it give me a selector? No, it doesn't give me a selector on the observable, it just doesn't merge. Sorry, I'm using a different syntax. But long and short, what it's going to do behind the scenes is it's going to merge all of these observables together. So getting back to the operators, there's a list of operators, and I'm going to go grab some documentation real quick and pull it up and bring it over. So on reactivex.io, which is kind of the place to find all information as it relates to reactive extensions, there's a list of operators, and these operators are categorized, and you can do all sorts of stuff. Like I said, you can buffer, you can do distinct, you can do selects, you can check first, you can filter, you can ignore elements, you can combine latest, you can merge observables together, and then you can then expand those observables back out. I was actually working on some of that the other day, where I had to like fan out and fan in, which is really complex and kind of broke my brain. But this is a great resource for just looking at the observable operators and kind of getting an understanding. Like I said, we'll click on, because we're talking about merge, right? So where was it? Here we go. So merge, and this is the other thing that I love, is it actually gives you like marble diagrams, and you can you can actually scroll through here and get an understanding of what this sequence is doing over a span of time. So this is a great way to kind of get involved and get to looking at the operators and seeing what they do. But I'm going to close that real quick. So what this code does under the hood is basically just merge all these observables together and say, give me a value. So anytime any one of these observables emits a value, it's going to give me that last value. So if this is executing and this is executing and another thing is executing, then I'm loading. And I can also set on the reactive command a execution, a can execute that is an observable pipeline itself. You'll note, well, you can't see that because that's small, but this is just an observable, right? A Boolean that tells me whether or not this function can or cannot execute. So I can do all of that. I can handle all of that mutation of state right here. So anytime any command is firing, my isLoading will update, and I don't have to explicitly go set that state. For me, that's a very powerful thing, because now I can look in one place and change the state and know every single time exactly where that state change is happening. So let's go ahead and actually run this code. Let's hope that I didn't break anything. Let's run this code and kind of take a look at what this means. It's still quiet. No one's asked any questions, so I'm assuming that that either everyone understands that what I'm talking about is just absolutely ridiculous, or somebody can teach me something that I don't know. Oh, there we go. That's code that you're not supposed to see yet. Yeah, okay. Oh, we're so smart. Is it going to do it again? No, it should just be on a timer. Anyway, so how many times have you had a login screen, right? So this is, again, contrived example, I know, but it's contrived for a reason. How many times have you had to look at an email address and validate that it's an email address, and then validate the password length, and then only after you've done that, allow the user to log in? That's a very common thing that I do in my applications, because I don't want you to go clicking buttons that you shouldn't be able to click. You know, the whole respecting can execute of a command is a very important thing. So here I actually have some code on this ViewModel. I should be able to find if I'm paying attention. Okay, yeah. So that validate, right? So I've got a validate function here, right? So the is valid that I'm setting is basically just setting when I'm saying when there's a value in the email address, when there's a value in the password, and when those two things validate, i.e. meaning that they meet my business requirements, whatever my business requirements may be. Maybe it's an email address, maybe it's a certain number of characters, maybe you have to have a special character. Once that's validated, is valid will be true, and then login will be able to execute. So right now you'll notice that I cannot log in. Like this login button is grayed out, like I can't really do anything. So I'll go ahead and put what we would consider a valid email in here. So I'll go ahead and put in my last name at gmail.com, right? And I have I think a 6-character password. So let's try it out. 1, 2, 3, 4, 5, 6. So you'll notice here now that my login command just lights up. I didn't have to go set the login command can execute. I didn't have to change anything. All of that happened as a result of this validity statement changing. So I'll actually put a breakpoint here so we can actually look at that. So, no, maybe I won't. Yeah, so notice it's checking to see based on 5 elements. So it's going to come back and tell me that this is no longer the case. But the second I come back over here and put a 6th element in, it'll tick and give me the value of that property right here. And this is just bound out, as we saw earlier, to my view to some text box. And I can show you that text box. You know, it's some XAML, just so that you can see it, so you know I'm not shooting you a line of smoke. Now, I will tell you that I am a fan of C# UI. I do like C# built Xamarin UI, but that's only because I started Xamarin in like the 1.3 version where C# was kind of the way to do things. And I don't really see a clear advantage to XAML other than the readability of the markup. But if you follow certain coding practices, that becomes a moot point. But you'll see here that this is just a text entry. It's just an entry. I give it a name so that I can add it to my bindings behind the scene. I set the placeholder text, which all of this I could technically do using code, but I do it in XAML to kind of make people warm and fuzzy. So it's just responding to that code, right? Like there's no setting of state. There's no additional processing that I have to do. There's no additional stuff. I don't have to go and check to see whether or not they input the correct number of characters. I don't have to write additional functions to do all that, although I did. Here, this is just a function that calls to other functions because it's functional programming. I did that literally just because it's functional programming. But you'll see here that I'm just checking to see whether or not the string is null or empty, and whether or not it matches my regex, and whether or not the password has a length greater than 5, right? And that's going to determine whether or not my code can light up. So now my login button hits, and as we saw earlier, that I have these bindings, right? Here we are. So we are changing the is loading based on, where are we? Okay, we're changing the is loading based upon when the is execute changes. So now when I click the is loading, my loading indicator loads because it's bound to this property which gets piped out. So I had said earlier that observables don't really play nice with UI kits. Another extension method that was written is this toProperty. What it does is instead of you having to do like so here I could do the same thing. I could do like a .subscribe. No. Observable that gives me an observable. I should give you subscribe, right? So it should give me some subscribe, and yeah, and then here I can basically say, is loading equals whatever the value is that comes off of it. I could very easily do that, but there's some niceties. There's some additional scheduling stuff that happens behind the scenes, some defers, so that you get some additional performance gains out of this toProperty. So it's a very useful extension method, and I actually use it a lot in my observable programming. But some earlier adopters of ReactiveUI don't use it as much. So it's just, I guess, one of those things. But you'll notice here, like I'm just setting it. It's firing off its thing, and it's trying to log me in, and then it's done. So it's changing state. It's reacting to the fact that the execution is happening. So the actual good thing about this reactive command is it is itself an iObservable, and he is executing is an iObservable. So whenever the value changes, it just ticks another value on the observable. It just pushes another value on that collection over a span of time. So again, this is a contrived example, but this is a very powerful example because it gives us a very good window into how we can combat some of the concepts of state mutation, that we don't have to explicitly set some is busy to true and do all of this work. Because when I first started Xamarin, what we used to do was we used to write like a state change. So we'd have some private things. We'd have some private void, state change, and that would be what would be responsible for changing all the state in the ViewModel. It became very cumbersome and very buggy very fast. And even though I was able to write unit tests for most of it, there was always some random race condition that I wasn't able to handle that would, say it was getting set here and then it was not getting updated here, or it was happening on a different thread, and I could never really lock it down. Once I converted to this style of programming, it became a lot easier to deal with. So I'm actually going to stop here for a quick second and ask, are there any questions to this point?
Yes, there is a question. Or I have a question.
Wonderful.
It's not in the chat. Going back to your actual content page there, I noticed that you were using would appear to be a non-standard Xamarin Forms page. It's called the login state : content page base, and I wasn't
Yes.
sure if that was something specific to Reactive UI or that was just something that you built that you liked using.
Thank you for the softball. Yes, that is something specific to Reactive UI. So I actually build these. I've actually got a library that I use now because I'm tired of rewriting code everywhere. So I write this abstraction in a lot of my projects. So this is a reactive content page, which is something that you get from Reactive UI, and all it does is really bind your view model to your page and does kind of the binding context updates for you. I can actually show you that code if you really wanted to see it, but you can also just trust me when I tell you, it's basically just setting the binding context and reacting to that iNotify property change. So basically what we're saying is that this page is a Reactive UI page or a Xamarin Forms Reactive UI content page that has a login view model as the binding context. That's really all it is.
Okay, so then my follow-up question to that is, you mentioned that for like if you're using like a library like Prism, Reactive UI works perfectly with it. If you wanted to decouple your view model from your page, could you still leverage a view model locator that automatically finds the correct view model for you instead of having this this tight coupling here? And I'm not saying that like this is bad code. It's just a different way of slicing the egg.
Right, and from an MVVM perspective, this is still MVVM, right? Like the view has knowledge of the view model, but the view model has no knowledge of the view, so like that's still respected.
Right.
But yes, this is exactly that. We are explicitly coupling it because we want to say, hey, this page has this binding context. Now that said, and I can segue over to it in a minute, but the other code sample that I have that I'm actually going to talk through, and Dan Siegel actually reached out to me right before Christmas and asked me to write a, let's see if we can get this to work. Yeah, he asked me to write a sample application for Prism and Reactive UI because a lot of people in the community have been asking the question, hey, I want to use Prism because Prism has a better navigation story or it has some feature that I really, really like, but I want to use Reactive UI and reactive extensions. How do I do that? So Dan reached out to me because we've both been drafting these questions for the better part of 6 months to a year now. And he was like, Rodney, can you just write a sample? No problem. So this is actually that sample, and I can spin that up and show you, but you'll notice here that I am using reactive content page, but you don't have to. There is a way to do it, and Prism respects it without it, but you don't have to worry about it. And that's kind of the whole thing, right? And that's the reason why we do it is because we know that you're going to want to have to set your binding context as a Xamarin developer. So in Reactive UI, we just got to do it for you. We just say, hey, just give us the page and give us the view model and let us do that magic for you so that you don't have to worry about it. Let me actually grab that. So I'll put that up here real quick. I've got a whole bunch of links on my other screen. So this is the actual link to that, and so that you can see it. This is the actual Prism maintained sample for this. It goes through and kind of breaks down. So I actually sat down and kind of broke down some of the Reactive UI concepts and gave you links to get you started to understanding how this thing is working, so that you can see kind of some of the fun things that Reactive UI gives you from the platform perspective. But this sample is using Prism's dependency inversion container. So it's not using Splat, which is what Reactive UI is. It's built on a service locator. Yes, I know service location is an anti-pattern, but it works. So,
depends who you talk to.
I'm sorry?
It depends who you talk to.
Well, I actually wrote an abstract basically saying, and I'm going to link it here. I wrote an abstract for a talk that I want to put together that says service location isn't an anti-pattern. You're just a bad developer. Because reality, like service location, dependency, inversion containers, they're just a tool, right? They're not an actual pattern. Patterns emerge from using the tool. So it's us, the developers, that use the tool improperly that causes problems as a result of the tool use. But there's certain things that you have to do that service location is literally the only way to do it. So what do? You use service location. So anyway, this is here, this is out there. Now it's on, you can see it, you can go grab it, and I'll try and make sure that it's provided as part of the talk. But yeah, this is just a way that I like to do it, and this is a platform nicety. You don't have to use this. You can use just a regular content page and set the binding context yourself. That's not a problem. So let me jump back into there. Are there any other questions at this point? Everyone's heads
I don't
spinning.
see. Yeah, I don't see any questions. I'm gonna assume everyone's nodding ahead back home.
Not a problem. So yeah, again, feel free to stop me because I have mentors in the reactive space that teach me things about reactive extensions that I don't know, and I bug them relentlessly. Like, hey, why are you doing it this way? Why do we do it that way? Because it's a paradigm shift, right? Like these things are not easy concepts. They weren't for me at least. Some people it's easy. For me, it wasn't. I'm actually going to go back and I'm going to bring up something. I'm going to talk about Xamarin Essentials. So we talked earlier about observables model events very nicely. This is basically me creating an observable pipeline around around Xamarin Essentials connectivity state change. So first thing I'll tell you is that yes, this is a lot of boilerplate code, but don't worry, we've got a NuGet library called Pharmacist. It's called Pharmacist because it literally generates reactive extensions. But it will actually wrap this code and give you an observable pipeline. So it actually does all of this magic for you, so you don't have to write this everywhere because this can become very tedious. But we kind of do some of that for you. But I wanted to show this here because it gives a very clean picture of I've got some event handler on top of an event. I've got some event that's going to come through. I'm going to pass that event down to the event handler, and that event handler is basically going to be set up to whatever the connectivity change is for Xamarin Essentials. So whenever this ticks, I will get an observable of the event arg that gets emitted. Now I can go further and explicitly only give you like the network connectivity or specifically the profiles, but I didn't for the confines of this talk because I just kind of wanted to give people a chance to chew on this a little bit. And it's the beauty of this is you'll notice here that we are explicitly disposing of our event handler. So again, I told you when I first started writing Xamarin apps, I created memory leaks everywhere because I didn't know that you had to do this. I came from a large scale enterprise web background, and I had no real knowledge of WPF, UWP, WinForms. I didn't know about event handlers in that way. So I was creating memory leaks all over my application. The beauty of this is that when this observable pipeline gets disposed, this event handler will automatically get disposed and cleaned up. So I'm providing a handler and removing the handler all in one statement. So I don't have to worry about, hey, is that set up correctly in my dispose method? Nope, when this class disposes, this will dispose. And it's all just done for me. That's probably one of the biggest things that drew me to this style of programming was I can take this event and now I can do stuff over it. And I no longer have to worry about each single event. So again, you saw earlier, I'm injecting that code into my ViewModel. Now, what I actually do most days nowadays is I create this as like a static global in my application because I just let stuff subscribe to it. But I wanted to show this from this perspective. I'm just injecting a service that has some IObservable connectivity, and this gets into object composition. So I can use this object, right, this observable, and I can compose it and just like you would a link query. And I can change the link query at different parts, and I can break the link query off and create separate link queries at different parts in the actual execution. And again, because it's linked, we get that deferred execution, so it's not happening right away. So I can say, hey, give me all the state changes, and then I can further then say, hey, just give me state changes where, come on, Rodney, good at programming. Just give me state changes where the access profile equals none, right? So now all of my downstream consumers, everything that uses this object composition will have this where clause attached to it. So I can then process however I want on these, but I don't actually want to do that for the purposes of this. I just want to kind of show that that is something you can do. You can compose objects and then create different branches of different pipelines at different points and do different functions as a result of those. And that's something that you can't do in the task parallel library, right? Like you just fire it off and it comes back and it does the function, it does the thing. Like I can basically say, hey, for these values, do this, for these values, do that, you know, over this sequence, do these things, and it's all coming from the same place. It's all composed from the same object. It's a very powerful thing for me when I am doing a lot of event-based programming, because I do that quite frequently. I'll branch off an observable and say, hey, at this point I want it to do this, or I want this to pipe out to a property, and I want this one to, you know, actually subscribe. So I said earlier that the subscription is where we actually do work. It's the subscription can be thought of as just a event handler invocation. It's really all it is, right? So you have like an event handler, you do !.invoke, same thing. It's just going to be .subscribe. So what this code is doing is it's saying, hey, give me the network event or the event args that have internet, and we're going to say start with true, and we're going to tell you that whether or not it's connected, right? So if it's connected, when it's connected, it'll start with connected, and it'll say, hey, it's connected. And then the second the first state change comes through, that's different than the current state change. And again, I told you their values over time, so it could technically tick through multiple times. So if I take this off, this will technically update every time a truth value comes through, every time true comes through. But because I have this on, it'll only update when this value changes. So when this value is changed, then go change the connected, right? And I'm just piping it out to a property. So again, this is just a method invocation. This is very similar to subscribe. I'm just piping it out. But what I'm doing here is I'm saying, hey, give me is connected, give me something that tells me whether or not the state, whether or not the state of the application is wireless. And then I'm also saying, hey, when there's no internet access, go and notify the user. So that's what you saw earlier when it first started up, because Rodney's smart and he forgot to change his code sample. So you'll also point out that I'm not actually using this one because I can't simulate network changes, but I can create a mock. And in my mock, I can simulate these network changes, and now I can test this service to verify that it works the way I want it to using unit testing. And I can also unit test my view model values over time and verify that the state of the that the state of the view model responds correctly to these change notifications. So that was one of my biggest qualms with the Xamarin Essentials when they first came out, was it was just these static classes, and I couldn't actually unit test the state changes. With observables, I can unit test the state change in a way that will allow me to verify, pardon me, that my view model is actually responding effectively to a state change. And the way I'm doing that is this. I'm basically just creating an observable, right? Because again, it respects the same interface, which it just has some, it just has some interface that says, give me some connectivity change observable, right? So take some events and pipe it out to some observable. So it's respecting the same interface. So it's giving me the same thing. And what I'm doing is I'm basically saying, hey, after 5 seconds, emit a value. That's all this observable.timer is doing. It's saying, after 5 seconds, emit a value. I can go further and I can do an interval and it'll say, hey, every 5 seconds, emit a value. So we're actually going to look at that in a second. I'm probably going to make it 10 seconds, and we're going to fire this up while I continue to talk so you can kind of see it doing its thing. So every 10 seconds, it's basically just going to tick through and tell me that there's no internet access. And when that happens, I've got something in my view model that will then notify. Yes, I got it. I have something in my view model that will notify the user. So this is another ReactiveUI specific concept. It's similar to the dialog service in Prism, but it's a way for dialogues to be pushed. I'm going to take that breakpoint off. It's a way for dialogues to be pushed. Yeah, here we go. And all of my breakpoints are going to start getting hit. So you'll see over here now that it's firing off events. It's just going to keep going. It's notifying the user and saying, hey, you appear to have lost the internet, right? So every 10 seconds, it's going to tell me again, hey, you have no internet. And now I can notify my user. I can go do some additional processing. I can do all of that using Xamarin Essentials, which is provided by Xamarin Forms team. And I can just wrap it in an observable pipeline, and then I can allow any consumer of that pipeline to operate on it. And I can notify the user. I can go do some background processing. I can go get values from cache. I can explicitly retry to verify that the internet comes back. I can do all these manner of things just by subscribing to this event, But instead of listening to the event through an event handler, I'm subscribing to the event through an observable pipeline, which is just, as you see, giving me a series of values over time. So again, this is a contrived example, but it kind of shows you ways that you can do stuff. So like I can also do the same thing with the battery changed event. And I can say, hey, when the battery gets to a certain point, I know my application doesn't respond as well, or hey, maybe we're not going to make network calls when you're low, or we're going to take you to offline mode automatically. I can do all of that just by responding to the observable. And I can have any view model, any subscriber, anybody that needs to understand that, deal with it in a very functional and orchestrated manner using link over a series of events. I'm actually going to stop this here, and we can kind of talk through that a little more. But basically, all I'm doing is handling this and popping up to the user saying, hey, you aren't doing the thing you're supposed to do because you don't have internet anymore, so go jump in a lake. So for me, where I started with reactive extensions and ReactiveUI was I started modeling events as observables, and I started to use events as observable pipelines, and it became a very, very useful tool. And then I started to use it to model asynchronous programming and started using less tasks and more observables. And now I still use the TPL, but I do a lot more work in these observable pipelines because it's just easier for me to conceptualize. It really takes turning yourself on your head and looking at the problem differently. But it's a great tool once you get used to it, because it allows you to model tasks and events as the same concept, and you can even merge like tasks and events together. So I can take an observable that's looking at a task, an observable that's looking at an event stream, merge those observables together and say, hey, when the task returns, but the event hasn't fired, go do this work. But when the task returns and this event has fired, go do something else. And I can put all of that in a very composable, succinct link statement that is readable to a human. I mean, like everyone knows what select many does. Well, let me rephrase. I still don't know what select many does most days because I use it and I'm like, wait, it doesn't work. But it's basically just a flat map, right? It just flattens out a list. I know what select does. I know what, I may not know what starts with does, but I know what where clauses are. And these are just link operators that we already know that we can use to compose processing over a stream of events or a stream of tasks or both or all or none. And it becomes a very powerful way to handle those things. So the last thing I'm going to show you, I think, is going to be in this Prism sample. I'm going to show search, and I'm going to show you that same search logic that I showed earlier. Yeah, I'm going to show that same search logic that I showed earlier, and show you how to implement search in like 6 lines of code. So this was just a Prism sample, so I don't even think this matters. So I'll just put code in here. Yeah, it just has. And then Prism will navigate and tell me that life is good. So this is just a NuGet package searcher, right? So again, I told you earlier that pharmacist wraps events. So I've got this UI element, which is just a list view. So I'll show you that it's just a list view, right? It's nothing special. And on that list view, there are a series of events. So I can look at all of the events, and this is the event API that's provided by pharmacist. And then I can say, hey, the item selected event, give me an observable of those event change arguments. And then I'm going to select them and observe on the main thread and then do some work. This is just setting the selected item to null, but this is the one that's actually doing the invocation here. No. Oh, I moved that to the view model. Rodney is smart. Yeah, here we go. So that goes in the view model, but I could technically do that to the text changed events on the view if I wanted to as well. As a matter of fact, I've done that on occasion. But here again, I'm just throttling for 8 milliseconds. So I'll go ahead and put some breakpoints in here so that you can kind of see. Oh, the select menu is not going to work, but I should be able to get to the pipe out. Okay, so I'll point out here that I'll go slow, right? So I put ReactiveUI in, and you'll notice that it didn't actually tick as soon as I typed in every single thing. It waited until I finished, and it waited for 800 milliseconds after I finished to actually start doing any form of processing. So before this thing actually lit up, it waited for me to finish typing. I didn't have to respond to every single text change event. So now it's going to check to verify that the term is valid. And again, I told you it's distinct until changed, right? So I'm going to show you later. Oh no, I'm bugging everything. So now I just have a list of NuGet packages that are of type ReactiveUI. Again, we talked about distinct until changed. I can't show it here unless I change the code, but you'll notice that if I take I don't know, it'll actually still do that. It won't do this part. So I'll check here, right? So if I take that out, notice it gives me a changed event, it hits, right? But if I put it in, oh, there we go, Rodney's being smart again. If I put it in and then take it out, it'll check, but notice it didn't actually call this code. That's because the value in the text box is still the same value as before. So we've said until that value changes, I don't want to do any work. I don't want to do anything. Just leave me alone until you actually have something for me to process. This is a very powerful thing for mobile developers because responding to every single text change, firing off a task to go hit an API for every single text change becomes very process intensive, and it will bog down your application and mess up a lot of things. But reusing reactive extensions and ReactiveUI and link over events, I can trim down the amount of processing that my application has to do. And you'll notice I've implemented search in, I mean, I cheated because this is technically part of the search, but that's a function call. I did this in a couple of lines of code. In a couple of lines of code, I was able to tell it, hey, don't do anything until the user stops typing. Don't do anything unless there's a value that's different than the previous value. Go do this work and return to the main thread. All of that was done in 6 lines of code without having to write any specific buffering, throttling nonsense. It's all handled for me. For me, this was powerful enough for me to stop everything I was doing and learn how to make better use of this concept. And again, ReactiveUI is not it's a full feature framework in the fact that it has all the features of an MVVM framework, but we don't force you to use everything. You just kind of use what you want and leave the rest behind. So I'll stop there because that's kind of really the last fun part of my my sample, and I'll ask if there are any questions. I'm looking on time. Oh, good on time.
I'm gonna give you an applause first. That was a wonderful talk with a lot of really great content on ReactiveUI. Does anyone has any questions? Feel free to open a mic or drop a line in the chat.
Everybody speak at once.
Everyone can
I'll ask a question. Like, does this make sense? Does this look like something that's useful to you as a Xamarin developer?
I think this makes a lot of sense on what you presented on. We had the conversation at the beginning. It's an opinionated way of doing things, and neither that's good nor bad. It's just an opinionated way of doing stuff. So you kind of have to jump in and say, we're going to agree with the opinions here. Yes. I personally really like how it can provide a lot of simplicity on state management, and that's something that's always interested me on it. And I think your presentation, at least for me, is giving me the push to try it again.
So I'll go ahead and put another disclaimer out there. There's a book. One of the legacy maintainers, Kent, wrote a book, UI and ReactiveUI. I have it on my shelf behind me. I've read it twice. It is a good read. Believe it or not, for technical books, it's actually not dry. It comes with a bunch of code samples. And when I mean a bunch of code samples, I mean a bunch of code samples. He literally has code samples for every piece that he talks through the book. So it makes it a little bit easier to grok. As a matter of fact, I was telling Andrew before we started that the last team that I was on, I actually forced developers to learn Reactive UI, and I just went out and bought copies of the book and just told them to read it. And after they read it, they were like, "Oh, it's really just link over events." And they were like, "Oh, we can." And because they understood event-based programming, they were able to jump right in and start being efficient like within a week. It was actually very impressive.
That's very cool.
Yeah, I definitely understand those concerns, and I agree with you. Like, it's hard for somebody else to come back behind you and maintain this code if they don't understand. But I mean, again, if you're not using link in a Xamarin application, like, I kind of question how good your Xamarin application is anyway. And then on top of that, well, if you already know link, well, this is just link with a couple of additional operators that you already don't know. So, you know, the learning curve for how to think functionally is hard. But once you get over that and you kind of, you know, you just kind of drink the Kool-Aid, it becomes a little bit easier and it becomes a lot of fun.
Right, and it's a lot of this just reminds me when I was in college. I learned how to program functionally with Scheme, and it's like at least there's not 100 parentheses for everything.
Right. Well, and that's kind of the point, right? Like, people say, "Oh, well, you're not doing functional programming unless you use F#," and I'm like, this is the best of both worlds for me. I'm a C# developer. I don't want to develop in another language. I like C#. I like the syntax. This gives me functional elements in a language that I know and love, and it makes my life really easy.
Right, right. No, I really like how like if I'm not sure if it was in this code file, but one of the ones you were showing how you were doing the method declaration, then you did the fat arrow, and you had it call two other functions there for like the email validation and the password validation, and it's just a different way of thinking. Like it's slick when it's all put together.
It is, and I find that a lot of people's adoption of it is exactly that, right? It becomes an issue of, hey, that's different, that's hard, we don't want to deal with it. But I will say this, that that functional programming as a concept is actually used all over the programming world. Again, Microsoft created reactive extensions, the concept of reactive extensions, but it's the de facto way to do things in JavaScript, Kotlin, Swift UI. So it's become the way that the rest of the world writes applications. So learning it is actually kind of better if you're going to be jumping outside of the .NET space. As a matter of fact, a lot of the people that I see in the .NET space using it these days are coming from RxJS and RX Java or RX Coca or RX Swift, and they're adopting functional programming because it's something that it's a knowledge base that transcends language specific concepts. Like the TPL is a .NET C# language specific way to do asynchronous programming, but observables is the way that asynchronous programming can be done in any language.
Right, and that's a really good point about how people from these other languages are coming in and really liking it. Like when I've worked in the other languages, functional programming, it's the way you do stuff.
Right, right. Like I said, I like it as a Xamarin developer because it's made my ability to respond to state changes so much more powerful.
Cool. All right. Well, are there any other questions? No? Okay. I am going to take screen back and we'll wrap up our meeting today. Let me share my screen. All right. And PowerPoint. All right. Cool. Well, thanks again for coming to our user group, our small corner of the internet, talk about Reactive UI and Xamarin Forms. I thought that was a really valuable talk. Before we jump into group time, our next session is going to be later this month, April 28th. I just spoke with our presenter earlier today and got them all confirmed. So they're going to be coming April 28th at 6:30 p.m. Eastern Time. We'll have another session. Thanks everyone for coming out, and we'll see everyone next time.